Welcome to Beta Training and Support Online Education. This is a question for the 10th standard CBSE Mathematics on the topic quadratic equation. This question appeared in the periodic test 1 question paper, question number 30. It's a 3 marks question. Let us see the question. This is the problem definition. This is the question. This is a 3 marks question which appeared in the question number 30 in a periodic test 1 in a school. Is based on the concept of quadratic equations. This is a question. The sum of the squares of 3 consecutive positive integers is 50. Find the integers. Understand the question carefully. Read the question carefully and find out maximum what you can get from that equation, from the question, so as to form a quadratic equation. That is what is required here. Pause the video if you would like to give this problem a try, and when you are ready, let us see the solution with the relevant concepts. See the key concepts before going to the solution in detail. The key concepts used in this problem we will see. This is a question on quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c equal to 0. Here a, b and c, the small letters a, b and c are real numbers and x is the variable. The degree of the quadratic equation is 2. You can see that obviously the highest power of the variable x, highest exponent is 2. The solution of the quadratic equation is called a root. It is the value or values also, because it can have 2 values, of the variable x which satisfies the equation. Since the degree of this equation is 2, it will have 2 roots. The roots may be real and equal, or real and distinct or unequal, or it may not have any real roots. Let us see how to solve this equation. In fact, there are 3 methods to solve a quadratic equation, and we will list them out here. A quadratic equation can be solved in 3 different methods. 1. Method of factorization. 2. Method of completing the squares. And 3. Using quadratic formula. In this video, we will present the method of factorization and also the quadratic formula. In fact, the method of completing the squares is not included in the 10th standard syllabus, but it will come later in the senior secondary syllabus. Now, the solution of quadratic equation by factorization method. Let us see. In this method, we factorize the quadratic polynomial on the left-hand side, LHS of the equation, by finding factors, which can be used to split the middle term, the coefficient of x. The middle term is the coefficient of x. And the constant term of the quadratic equation will be the product of the 2 factors. This you have already learnt in the 9th standard. So it would not be a big problem for you. You just have to solve that by the method of factorization. Let us see this. The second method is using quadratic formula, the other method. In this method, we first find the discriminant of the quadratic expression on the left-hand side of the equation. In the quadratic equation ax squared plus bx plus c equal to 0, the discriminant denoted by capital D is equal to b squared minus 4ac. Evaluate that expression b squared minus 4ac. If that expression D is greater than 0, the roots are real and distinct, the real and unequal. If d is equal to 0, then the roots are real and equal. If d is less than 0 or a negative value, the roots are imaginary or there are no real roots. Now coming to the quadratic formula. In this method, we use a formula that is called the quadratic formula. If the roots are real, that is, if the value of d, the discriminant, is greater than or equal to 0, then we proceed to find the roots of the quadratic equation using the quadratic formula as given below. This is the quadratic formula. X is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. The quadratic formula, as you can observe, it involves only the coefficients and the constant term, coefficient of x squared, coefficient of x, and the constant term, a, b, and c. There will be two roots. In a practical situation, only one root may be a feasible solution depending on the condition given in the problem. In this question, we have to take only the positive root because it is given that in the question that it is a positive integer. Solution to the given problem. Again, we present the question. Here is the question. The sum of the squares of three consecutive positive integers is 50. Find the integers. Solution. Let one positive integer be x. Consecutive numbers means the numbers such as 2, 3, and 4, like that. Next numbers. So, example 2, 3, 4, 3, 4, 5, and so on, which differ from each other by 1. So, hence if we assume that one positive integer is x, then we can say that the other two consecutive integers are naturally x plus 1 and x plus 2. So, this is the assumption. Now, we come to the forming of the quadratic equation. This step is a very important step. Here you have to be very careful to read the question according to the question. Now, according to the question, the sum of the squares of the three positive integers is equal to 50. That is, we have to square each and every each consecutive positive integer, each positive integer. Say x is square, x squared plus x plus 1 the whole squared plus x plus 2 the whole squared plus of course x plus 2 the whole squared is equal to 50. We have formed the equation now. We have to simplify this equation. We have to bring it to the standard form of the quadratic equation. Ax squared plus bx plus c equal to 0. That form we have to bring it. So we have to simplify this expression on the left hand side. How will we do that? Just expand x squared plus x plus 1 the whole squared. You know that identity a plus b the whole squared, x plus y the whole squared, that is x squared plus 2x plus 1 plus x plus 2 the whole squared similarly will be x squared plus 4x plus 4 equal to 50. So we get on the left hand side 3x squared plus 6x plus 5 is equal to 50. So transposing that 50 to the left hand side, we get 3x squared. Of course, with change of sign, it becomes minus 50 there when it comes to the left hand side. So 3x squared plus 6x minus 45 is equal to 0. This is the required quadratic equation which represents the question. Now, solving the quadratic equation, by the method of factorization. As well as quadratic formula, we'll see that later. First, let us solve this quadratic equation by factorization. This you have already done in 9th standard. So, it just you multiply the coefficient of x squared with a constant term with the appropriate signs. 3 into minus 45, we will get minus 135. Then find by prime factorization of minus 135, two factors whose sum will be plus 6. That can be done easily by prime factorization. I think you divide by 5 first, because 135 ends in 5. So easily we can say 5 and proceed to find the other factors. In fact, it will be 5 into 3 into 3 into 3. That is 3 times 3. Actually, 5 into, once you divide by 135 by 5, what will you get? 135 by 5. 20. 20. No. Yeah. 27. Yes, exactly. 135 by 5 will get 27. 27, again you can do it by prime factorization by 3. So you will get 3 into 3 into 3 again. So by proper combination of these prime factors, 3 into 3, 9, by trial we can find out. 1 will be plus and 1 will be minus here. Be careful, because there is the second term, there is a coefficient of x is plus here. So the greater factor, the bigger, larger factor will have a plus sign. So plus 15. We have arrived at 5 into 3, 15. And the other two threes can be combined together into 3 into 3, 9, which carries a negative sign there. So plus 15 minus 9 will be the two factors whose sum is plus 6. Now we proceed to split the middle term. This is a rather easy process. We know we can change the order anyway. Here I put minus 9x plus 15x minus 45 equal to 0. We have split that plus 6 as one positive factor and the bigger factor is a plus sign. Minus 9x plus 15x. You can also put it as plus 15x minus 9x, no problem. You can somehow you can get the factors, the same factor. Now you take 3x outside in the first two terms into x minus 3 within brackets, and plus 15 into x minus 3 within the brackets. You find that x minus 3 is a common factor which can be taken out. Of course, equal to 0 comes on the right hand side. Now you see there, x minus 3 into 3x, sorry, there is a mistake here. It should be 3x minus 15, but anyway, 3x plus 15, we are not going to use it there. We are not going to use a negative value. It should be 3x minus 15, or x is equal to minus 5. So that minus 5 will not appear here. That you can correct it. Taking the positive root only. So since the negative root we are not going to take, doesn't matter. We are going to take only the positive root. We can directly give the positive root. We don't have to take the negative root at all. So taking the positive root only, we get the value as x is equal to 3. Hence, the three consecutive positive integers are 3, 4 and 5. This is what we get here. Okay. Then you come to the solution by quadratic formula. Is much easier than this if you could do it here. Let us solve this. 3x squared plus 6x minus 45 is equal to 0 by quadratic formula. Comparing this equation with the standard form of the quadratic equation, ax squared plus bx plus c equal to 0. We get A equal to 3, B equal to 6, and C is equal to minus 45. The discriminant capital D is equal to B squared minus 4AC. So D is equal to B squared, B is 6, so 6 squared minus 4A minus 4 into A is 3 and C is minus 45, minus into minus plus. So it becomes 36 minus of minus 540. Combining these, we become plus there. So D is equal to 36 plus 540, which is 576, which is greater than 0. So since D is greater than 0, the roots are real and distinct. Now we proceed to find the roots using the quadratic formula. See here, x is equal to minus b plus or minus square root of b square minus 4ac by 2a. It is equal to minus 6 plus or minus root 576 whole divided by 2a, that is 2 into 3. Since d is equal to b square minus 4ac, which is equal to 576, already found out. B is equal to 6 and a equal to 3. So substituting these values we get, and we simplify the value, you get minus 6 plus or minus, there are two values here. We take only the positive root. In this question we are given only the positive value, so don't bother about the negative value. In most of the word problems we consider only the positive value because they are real life, they are actually they mentioned in the question. According to the question we can find out the solution. Here take the positive root, we take x is equal to minus 6 plus 24 or 24 minus 6 by 6, which is equal to 18 by 6, that is equal to 3. Again we get the same answer. X is equal to 3, 3, 4, 5 are the positive integers, the consecutive positive integers. 3, 4, 5, which is the required answer. Hope you understood this. Thanks for watching, and please subscribe to our channel, Beta Training and Support Online. Thank you.